Now it is okay.
हाँ सर अभी आ गई.
Okay. So are you able to view the syllabus, everyone?
Yes sir.
Okay.
Yes, sir.
Okay, student, please concentrate that we have completed our unit number 1. That is what is alphabet, string, language, graph and tree, concept of basic machine, concept of finite state machine, then concept of Millet and Murray machine, conversion Millet to Murray, then Murray to Millet, okay? Both conversions, FSN with epsilon mu, that is a NFA with epsilon mu, then minimization of FSM, that is minimization of finite automata, and parts are covered this second unit, that is building RE, conversion of RE to DFA, then DFA to RE, okay? Maybe this is remaining, uh, or you can tell me whether it is done or not. Decision algorithm of regular for regular sets. So after this, we have to start with the concept of grammar. That is the third unit, which is our third unit. Within this, basically, we have to understand two kinds of grammar. There is a context-free grammar mainly, and the regular grammar. Already, you have seen some part of regular grammar within this regular expression and a regular language. So, can anyone tell me that what is a regular language or what is a regular expression? Just whatever you know, exact definition is not required. Whatever you know about the regular expression or regular language, maybe about grammar you don't know, but regular expression you know. What kind of expression you called it as a regular expression? Any example? Can you give me any example? Students, please reply. Any example of regular expression? Have you solved these examples? That is RE to DFA or DFA to RE. You have solved these kind of examples? Yes or no?
Yes sir.
So
Yes,
just
sir.
give me any example of regular expression. Any example. So we can start with our concept of grammar.
1 * 0.
Okay. 1 * 0. So I will close this syllabus PDF now. As I told you that we have completed the first two units. Now we have to start with the unit number 3. Total 5 units we have to complete within this syllabus to complete the concept of this theory of computation. That what is the theory behind the computation. So we have understood that how the machine is designed if the problem definition is given. Then these regular expressions are used to identify the type of language. For example, one of your friends says now that 1 star, just a minute, I will share the slide now. That one of your friends says that 1 star into 0. So star means what? Star means what? 0 or more repetition. For star, we can write down like this: 1 star is equals to epsilon, then 1, then 1 1, then 1 1 1, then 1 1 1 4, and up to n. Understood? It is correct? 1 star? Yes or no?
Yes.
And when we write down 1 star into 0, it means every string is ending with 0. 0 is compulsory. We can write down like this, that is epsilon. There is no repetition of, there is 0 repetition of 1 into 0. It means we can, instead of this, we can write down only 0. and then we can write down like this: 10 110 or 1110 likewise. Understood? So these kind of regular expressions are able to produce a particular restricted set of strings, and these regular expressions are generating this kind of strings, and these strings are going to form the language which is known as a regular language. Okay, so within this regular language we are not able to remember the previous input, or the we are not able to store the input. So for that purpose there is another kind of language which is known as a context free language. So we have to understand that. We will see this difference later on, because you don't understand the words within this difference now. So for that purpose we will understand that what is a context free language and what is a context free grammar. What is the need? If we have the regular languages, then what is the need of this new language? Okay, or if we have the regular expression, then what is the need of grammar? That we have to understand here. So suppose there is a language which is not regular. Now what is a language which is called as a not regular language? That we have to understand. Okay, so can language can be recognized, so that we have to understand here. So regular language, as we know, that it is accepted by the finite automata. Okay, and if you observe this Venn diagram, that regular language is a part of, or we can say a subset of context free grammar. And this context free uh, this context free language, in short form it is called as a CFL. This context free language is represented by or produced by context free grammar, and it is accepted by a push down automata, like a finite automata. Finite automata is what? It is a mathematical model of FSM. So here this push down automata, it is the another mathematical model for the different kind of machine, which is having the memory element. Here we have the memory element. In FSM we don't have the memory element. Okay, that is the disadvantage here. So let us consider the example. If we want to represent a palindrome string, okay, so palindrome string we cannot represent it with the regular language. Okay, so binary palindrome string, if we consider binary palindrome string, means binary means only 0 and 1. A palindrome string which is made up of 0 and 1. Okay, so palindrome string can be odd or it can be even, like this. It is a odd palindrome string. Odd palindrome string. And how we can write down the even palindrome string? Can anyone tell me? Even palindrome string, it can be like this. It is a even palindrome string. Okay, so it is one of the example, that is a palindrome string. So we have to check whether it is a regular or not. Okay, so it is not regular, because it can be a even palindrome string, it can be a odd palindrome string, and it can be proved. Okay, how it can be proved? So here it is one of the example, that suppose it is a odd palindrome string. So if we consider this odd palindrome string like this example, so 1 is constant in the middle, number of zeros can be increased on the left hand side, on the right hand side. So in short it is written as 0 raised to n 1 0 raised to n. This n is capital, represented as a capital N here, if you can observe. Okay, so there is one concept of pumping lemma, okay, which is going to prove this, that it is not a regular. So pumping lemma is over or not, to show that language is regular or not. Just tell me that you know about the pumping lemma, students.
No, sir.
Okay, so we'll discuss it later on. Just before that, we will just go towards the context-free grammar now. Okay, so the languages which are not falls in the category of regular languages are check for the context-free languages, that they are context-free languages or not. Okay, so palindrome string is a context-free language. Why it is a context-free language, that we have to understand here, because it is going to support the recursive substitution. Now, what is the recursive substitution? That we have to understand here. So, there is a concept of grammar. Now, what is the grammar? This kind of productions, that is a capital letter on the right hand side, arrowhead, and on the left hand side, there can be a combination of small letter and the capital letter, which is known as the terminal and non-terminal. So, if you observe that all these five are known as the productions, okay, and the left hand side symbols other than capital letter, all are considered as the terminal symbols. So terminal symbols I can say small a to z, 0 to 9 numbers, and all the symbols that you are going to use like epsilon, dollar, hash, all are considered in the category of terminals. And if we consider the non-terminal, if we consider the non-terminal, then all capital letters from A to Z are falling into the category of non-terminal, and this non-terminal is also called as a variable. Is also called as a variable. These are the synonyms provided to this A to Z. Okay, so I just remove this. Just wait a minute. So variable or a non-terminal. All these are capital letters are known as a variable or a non-terminal. Understood? So and when we are going to write down this production, so this production is written as, just a minute. We have written these productions on the separate line. If you observe, production number 1, production number 2, production number 3, 4, and 5. And on the left hand side, if you observe, there is a common non-terminal, there is a common capital letter, that is A. So instead of writing down it on the separate line, we can write it down it like this. We can separate each production with the one vertical line. So it is the first production, it is the second production, here it is the vertical line, here it is the third production, another vertical line, fourth production, and it is the last vertical line, and it is the fifth production, last. So same number of productions and same content within the
In the
productions,
productions.
but separated by the vertical line. Understood? It is known as an grammar. And specifically, it is a context-free grammar. And what is the restriction of this context-free grammar? That LHS is consist of only one non-terminal. LHS is going to consist of only one non-terminal. On the right hand side of this arrow, there is a RHS. RHS can consist of terminal only or only non-terminal, okay, or a combination of terminal and non-terminal. Combination of terminal and non-terminal, okay, and that combination it can be like this: terminal first or non-terminal first. It can be anything. Okay, so this combination, that is a terminal and non-terminal, it is known as a sentential form. It is known as a sentential form. Okay, combination of terminal and non-terminal, it is known as a sentential form. So how does this context-free grammar works for the palindrome? Okay, so let us consider this grammar which we are going to use for the context-free, for the palindrome string. So let us consider this example. 0 1 1 1 0. It is a palindrome string. If we read it from the left hand side, then it is 0 1 1 1 0. And if we read it from the right hand side, then again it is 0 1 1 1 0. Means same. It is a palindrome string. So how we can derive it? How we can generate it from this grammar? So it can be generated in such a way that if we want to generate it from the left hand side, then we have to check that whether it is starting with 0 or 1. Then which production is starting with 0? This production is starting with 0 and this production is starting with 0. But after 0 there is nothing. So if we choose A produces 0, then we cannot extend this string further to generate this 1 1 1 and 0. So we have to go with this first production. So in this way we are going to write down this first production, that is 0 A 0. After obtaining this, we need to replace the non-terminal. These are the terminal symbols 0 and 0. We have to write down the replacement of this A. So how we have to substitute for this A? So next we have to check that what we have to generate next, that is 1. So where we can obtain this 1? We can obtain this 1 here and here also. So why we are not going to choose this one? If we substitute 1 here, 0, 1, 0, then this string becomes 0, 1, 0. We have to obtain 3 ones between these two 0. So it will not work. So we have to consider this production. That is the second production, which is a 1, A, 1, 0. Again, we have to substitute for this A. Now what we have with us from this string, we have now 0 1, first 0 1 and last 1 0. The middle one is remaining now. Okay. So for this A, now we are going to substitute 1 1 0. So for this A, we have substituted this one. So in this way, we are going to obtain the string. And whenever we are going to write down this transition, we have to write down the proper reason also. So how we are going to write down the reason? So I will show you now. Just wait a minute. So in this way, we have to write down the production. There is A produces. Suppose I am going to write down A0, A0. Next, I have written that instead of this A, I replaced this A, and for this A, I have substituted 1A1, 0. So here I will write down because A produces 1A1. It is the reason. Okay, so that we have substituted this thing. Next, 0 1 for this A now we are going to substitute 1 1 1 0, remaining thing as it is, if you can observe, only we have to substitute for this A. So here we have to write down the reason because A produces 1. Okay, and then in last we can show that A produces, here also A we can write down final answer as a 0 1 1 0. It is the string that we want to produce. Yeah. In this way, simple way we have to generate the string from the grammar. Understood? Any doubt within these, students? If you have any doubt, then please tell me. What is the context-free grammar definition that we have to understand? So some tuples we have to use here. That is a VTPS. We have seen that finite automata is defined with the help of these tuples: Q summation del Q0 and F. Similarly, here the grammar is shown like G is equals to VTPS. Now, what is V? V is the set of variables. Okay, we have seen this grammar now. Here, variables and non-terminals. I have told you, capital letters are the variables and terminals. Okay, so here the set of variables or non-terminals are shown with the help of V. Okay, next terminal symbols are shown with the help of T, capital T, and the productions are represented with the help of P, and S is the starting symbol or the starting variable, and it is always a non-terminal. There is a variable as we label it as a start variable, means the starting non-terminal. Clear? So here it is an example. If we have these productions, so we can list out our tuples in this way that A is the non-terminal, 0 and 1 are the terminal symbols, it is a production list, P and A is the start symbol. Clear? So now there are some more examples about the this context-free grammar, that is a parenthesis matching, sentence checking. Okay, so if we consider this parenthesis matching example, then it is a palindrome. It is a kind of context-free grammar or not, that we have to check. So how directly I have written this? That we know that parenthesis, balanced parenthesis means what? If we have the opening bracket, then we must have the closing bracket. Okay. If you observe this example, there is a pair of opening and closing bracket. Then this opening and closing brackets having the different opening and closing brackets means it is a separate set. This one is the second separate set, and it's the third separate set. Okay. So if we write down in this way, that is S produces or any A, B, anything produces a parenthesis. So it is going to produce only one pair of open and closed parentheses. So if we want to repeat it, so for that purpose, we have to write down like this, that if we want to produce the parenthesis in between, okay, means like this, in between if we want to produce the parenthesis, then we can write down the production in such a way, parenthesis as parenthesis, okay. How we can replace it? So as produces as parenthesis, opening parenthesis as closing parenthesis. So for this as we can substitute this one, so it becomes in this way. Understood, students? Yes or no? Please tell me fast. Do you understood this thing?
Yes, sir.
Now it is about the internal, means if you want the parenthesis within a parenthesis. If you want a parenthesis after a parenthesis, then we can write down like this. That is S produces S and S. Okay. And instead of this one, that is this single parenthesis pair, we can use at the production like this. That is, we can use directly this production. That is opening and closing parenthesis. Then S S. Now, if we don't want any internal parenthesis, we want like this, then we can eliminate this S. And how we are going to eliminate this S? With the help of epsilon. So how we are going to write down the production, that is opening S, then closing. Then for this S, we can substitute epsilon. So it will become opening and closing parenthesis. So we are going to obtain this. So no need to include this production. We are going to write down this production. And this S into S means what? Suppose we write down like this. S produces S into S. And suppose I have written here, that is opening parenthesis S, closing parenthesis, and then S. Means for this S I have substituted this thing. Okay. So I can write down in this way that for this S, suppose I have substituted epsilon, then it becomes opening and closing parenthesis, then into S. Then I can produce a string like this again, S, S, closing parenthesis here, just a minute. Closing parenthesis here, and for this S, I can substitute anything. Okay, so how I can substitute opening and closing parenthesis, then S. For this S, I can substitute epsilon if I want only the opening and closing parenthesis like this. Yeah. If I want the inner parenthesis, then I will write down in this way, like this. Okay. So how we are going to produce the grammar? I just remove this all in this way. Yes. So how we are going to interpret this particular string? So if you observe here that this is the separate pair, this is the separate pair, and it is a one another pair. So one, two, three, and this outer is the fourth one. It is the complete pair which is going to enclose all these things. So we can start like this, that is S produces, opening parenthesis S, closing parenthesis. Then between this we can write down the different thing, that is S into S. Then suppose leftmost derivation, I am going to use leftmost means first this left side non-terminal we are going to replace first. So we can write down in this way, that is this S is again replaced with SS, S, S, S. So three things we are going to obtain. S 1, 2, 3. Okay, 1, 2, 3. So we can proceed further like for this S, for this first S, We can substitute like this 2s as it is. Now, how many parentheses we require here? 1, 2, and 3. 3, okay? So, 2 already obtained. So, we have to write down in this way. That is S, 2, 3, S, closing bracket. That will be written in this way. That is 1, closing parentheses. Again, here, 2, this thing we have to do. 1, 2, 3. Okay? And S, bracket complete. Then we are going to write down like this opening bracket, opening bracket, then opening bracket. Here we write down epsilon 1, 2, 3 in S into S. And now we are going to write down this 1, 2, 3. This epsilon will be removed. 1, 2, 3, first, second, and third. Then for this S we can substitute our opening and closing parenthesis S, and S here this will be epsilon. So 1, 2, 3, 1, 2, 3, and here is epsilon. So we will substitute next here. Now for this, this one, I will share this slide again. Okay. So we are going to simulate it very easily. So any doubt within this, students? How to simulate the string? Understood or not? Similarly, it is 0 raised to m, 1 raised to n, and the value of m is greater than or equals to n. So it is context-free grammar, yes. For this also we can construct a context-free grammar. How we can construct that? Number of zero. Suppose number of zeros are like this, 0, 0, then 1. Okay, so m can be greater, means suppose 2 here and it can be 1. Okay, or if it is 2, we can keep it as a 2 also. Okay, so you can simulate for this string. So these are the some examples about the context-free grammar. If you want to understand the derivation, that is structure of the production, as I told you that it is the left side of production which is known as the head also. Then it is a derivation, this arrowhead is a derivation and it is the body. That is what it is the combination of this alpha 1, alpha 2 it is given here, it is a combination of terminal and non-terminal. Okay. So terminal symbols, small letters are considered as the terminal symbols, but not only the small letters. Okay. All the other symbols like dollar, hash, then 0 to 9 numbers, these are also the terminal symbols. Capital letters are the non-terminal symbols or the variables. Okay. But we have to concentrate when we are going to write down this x, y, z. So when we are using this as a non-terminal or variable, you have to write down them in the capital letter. Okay. So here if we consider this regular expression here, a particular expression, so it is representing here these are the what variable. Okay, these are the terminal symbols. This star is also terminal symbol, plus is also terminal symbol. It is 4. This is the variable. Means a non-terminal. This distance is the variable, non-terminal. Okay, and this is the terminal symbol. Operators are also terminal symbol. As I told you, plus, this multiplication, this plus, these are the terminal symbols. Okay. Now we have to understand what is derivation. Okay. So derivation as a we have to understand that. Just wait a minute. I will tell you that what is the derivation. So if a grammar is given to us, okay, and if we want to derive a string, so as per just I tell you that derivation means you are deriving from head to the body, okay, and recursive inference means from body to the head. Now what is body and head? Already we have observed that from head to the body means it is a derivation, okay, and from body to the head means it is a reverse inference. Clear? So as we have already derived the string like this, that is 0, a 0, then for this a we are going to substitute the sum 1, then it is 0, then it is called as a derivation. It is called as a derivation. So we have to observe the two kinds of derivation here. That is the leftmost derivation and the rightmost derivation. So now it is the grammar provided over here, and from this grammar we have to generate this string. So what is the string? A star in bracket AB plus 10 bracket complete. So just observe the grammar that we are able to produce this string or not. All these things we have parentheses are provided in the grammar or not. Yes, it is parentheses are provided. Then operators, multiplication operators, plus operators are given. Yes, multiplication and plus operators are given. So how to derive the string? So first we have to consider the leftmost derivation. So in leftmost derivation, we have to substitute for the leftmost variable first. That is for the leftmost non-terminal. Okay. So let us start. So we start with the E because E is the starting symbol here. From this E and F, E is the starting symbol. Starting with E, which production we should consider? So as we already know that bracket is given preference first. So bracket means this addition will be computed first and after that there is a multiplication. So we will write down the higher part first, then we are going into the lower part. As we already know, if we write down the uh, expression like this, that is suppose 1 plus 3, okay, then how we are going to write down in terms of the tree? So the tree will be written like this, that is multiplication is afterward 2, but plus operation will be first. That is addition of 1 and 3 will be here, and then this addition is passed on to the multiplication. That is 4 is passed on to this multiplication. Then what is the multiplication? 2 into 4 is the multiplication. That is the 8. Okay. It is the execution structure. Understood? That is in tree the lower part is executed first. So similarly we have to start with from the higher and going up to the lower. It is called as a derivation. Clear? So we have considered the multiplication first, and as we know it is a leftmost derivation. It is a leftmost derivation. Okay. So here we have to substitute for the leftmost variable. So two variables are present here, two non-terminals are present here. So among these, we have to consider the left one. So it is highlighted with the red color. So now this E we have to replace. So how we have to replace this E? So what is the expression here? Before multiplication there is a letter A. There is a terminal symbol A. So where we can obtain this terminal A? From this F, production of F. So to obtain this production of F, we need to replace this E by F. We need to replace this E by F. So we are going to replace that E by F, and then that F is replaced by AF. Now as AF is obtained here, we have to eliminate this F because only A is required. So for this f, we have to substitute the epsilon. And it is a leftmost direction, so we have to substitute the epsilon for this first. So we are going to obtain the A star E. Now here only one non-terminal is there, so we are going to replace it. So after this A star, what we require mainly, we require the brackets. So this E is replaced with the production of the brackets, opening and closing bracket. So if you observe, it is replaced like this. Okay, opening and closing bracket is obtained. Now within that we require a plus sign. Within that we require a plus sign. So this E is replaced by E plus E. E is replaced by E plus E. Now we have two non-terminals. So leftmost we are going to consider, which is highlighted with the red color. Then next, this E is replaced by F, because E can be replaced with the F only when we are going to replace that F, E by F, and F will be replaced by A and B. Okay, so this will be replaced in this way. AF. Then next, F is replaced with this. F is replaced with this. Next production, that is with the BF. So AB is obtained, and this F is replaced with the epsilon. So AB plus E. Now 1 0 we have to obtain. So 1 0 again obtained from the production of F. So we have to replace this E by F. Then F is replaced by 1F, and then later on it is replaced by 0F, and F is replaced by epsilon. In this way we are going to obtain the string. Understood, students? Any doubt within this?
No doubt, sir.
Understood this derivation? How this derivation is obtained? Now similarly the rightmost derivation. Now here we have replaced the leftmost symbol. In rightmost we have to replace the rightmost symbol. So let us see now. It is the leftmost derivation. Now we have to observe the rightmost derivation. Okay. So if you observe, we are going to replace this E. Here we have replaced this left side E first. So how we are going to replace it? So obviously we require the parenthesis on this right hand side of this multiplication. So we replace this E by parenthesis E parenthesis. Okay. Then this E will be replaced by what? E plus E, because we require a plus sign. So here you can observe. Now within this 3E, the rightmost E is this one, which is highlighted with the red color. Okay. So this E will be replaced with the F to obtain this 1 0. To obtain this 1 0. So this E is replaced with F, and this F is replaced with first 1F, and then this F is replaced with the 0F, and then that F will be removed with the help of this epsilon transition. Next, these two E's are remaining here. So rightmost is this one. So this E is replaced with the F again to obtain this AB. To obtain the AB. So it is replaced with the F. Next, this F is replaced by AF, and then next this F highlighted with the red color, it is replaced by BF, and then this AF is replaced with the epsilon. We will going to obtain AB. Now last E is remaining. Now it will be replaced with the F, and then it is replaced with the AF. F will be removed with the epsilon, and then we are going to obtain the string. So it is called as an rightmost derivation, and it is called as an leftmost derivation. Understood? What is leftmost and rightmost derivation now? Clear?
Yes,
Yes,
sir.
sir.
Any doubt within this?
No, sir.
So there is an example within your question paper that obtain the leftmost and rightmost derivation for the given expression. So please try to solve it correctly. Okay. So for every leftmost derivation, there is a rightmost derivation and vice versa. It is true. Can we produce a leftmost derivation and rightmost derivation for the string? It is possible. Yes, it is possible. And we are going to prove it with the help of past tree. We are going to show that. Thus, every word generated by the context-free grammar is having the leftmost and rightmost derivation. Every word means every string, whatever is the string. We have observed this string. These strings are generated from this grammar. Okay. So that is also true that we are going to prove it with the help of the reverse direction or with the help of the tree, past tree, there would be a word which can be more than one leftmost or rightmost duration, may be possible depending upon the grammar, which is called as the ambiguous grammar. Okay, if we have the more than one past tree or more than one leftmost derivation, then it is ambiguous grammar. We have to observe that. So what is past tree? That will be in the next session. Clear? Any doubt, students? Do you have any doubt?
No, sir.
So we are going to close the session now. Within this session, what we have understood? What is the context-free grammar that we have understood today? Okay. The simple definition of context-free grammar. It is represented by VTPS. Okay. That V is the terminal. Uh, sorry. V is the set of non-terminals or the variables. T is the set of terminals. P is the production, and S is the starting symbol. Understood? So please try to remember this thing. Clear? So we are going to close the session now. So any doubt, students? Should I close the session?
Yes, sir, no
Yes,
doubt.
sir.